We got a 10 kilogram box initially at rest, moves along a smooth horizontal surface. A horizontal force is applied to move the box. The magnitude of the force changes as a function of time as shown. Take the positive direction to be the right. So first of all, they say rank the magnitudes of impulse applied to the box in each 2-second interval. So A 0 to 2 seconds, B's 2 to 4 seconds, C's 4 to 6 seconds, D's 6 to 8 seconds, and E's 8 to 10 seconds. Rank them. Well, the impulses are going to be the area on this graph. So they need to find each of the areas. So from 0 to 2 seconds, we're sort of talking about this green area right here. So you can do base times height, so 2 times 3 times a half. So that's going to be 2 times 3 times a half is 3 there. So then you can look at the next area, they say 2 to 4 seconds. So that's just a box. So that's 2 by 3. So this area right here is 6. And then this area right here, 4 to 6 seconds, you can see it's almost 6 there, but we got half of a little box taken out there. So each box is 1 unit, so that's going to be 5.5. Then we've got this little area here, also a triangle. That is going to be a base of 2 times a height of 2. Half of that is going to be 2 overall boxes. And then finally, we've got this, don't forget, last little box here. So it is also the same shape there, and it is going to be -2. But it is important to realize that they did say the magnitude. So that negative won't matter. So when we do the greatest impulse, that is going to be B is greater than C here, which is greater than A, which is greater than D, which is equal to E in terms of magnitude. And how do we justify it? Because we found their areas, and that's how we know how to do it. So on this next one, it says, identify the equation that relates force and momentum. It's simply force times time is equal to change in momentum. And how can the momentum be found with a force versus time graph? Well, we know that the areas are the impulses, which are the changes in momentum. You got to be careful about that. It's not equal to the momentum, it's equal to the change. So now let's talk about plotting that. We're going to use this graph right here in order to plot some of this data. So maybe I'll sort of keep this on the side right here while I plot these. So on here we want time, and that's going to be in seconds. And so we'll do it every second. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds there. And then over here we're going to want momentum, which is measured in kilogram meters per second, will be our unit. So if we look right here, we're going to start out 0. It says at rest, so we have 0 momentum. We need the area of this little chunk right here to get after 1 second, and it's 1 by 1.5, and half of that, so it's 0.75 there is the momentum at that point. And each time, these are all positive areas, so they're positive changes in momentum, so we're going to be adding it on there. We know that by the end of this 2 seconds, we get up to 3 units of momentum. We've already mentioned that. After 1 more second, look, there's 3 boxes. We're going to have 3 more units of momentum. We're going to be up to 6. 3 more boxes here, 3 more units of area, 3 more units of momentum. Then after the next one here, so we get up to 5 seconds, we've got 3 more boxes, so we're going to get up to 12. Next time, be careful. We don't have 3 boxes. We have 2.5 boxes right here. So we're going to add 2.5 here to get up to 14.5. Then we have 1.5 boxes on that little area there, so we're going to get up to 16. Then we have just half a box right there, so we're going to get up to 16.5. Then we lose half a box. That's half a box of negative under the thing, so we're going to lose half. So we're back down to 16 again. And then we are going to lose 1.5 boxes, so we're down to 14.5. So then we've got to go and graph all of this right here. So we're going to start at 0. At 1 second, we're going to be at 0.75. At 2 seconds, we're going to be at 3. At 3 seconds, we're going to be at 6. 1, 2, 3, 4, 5, 6. At 5 seconds, we're going to be 3 more than that. 1, 2, 3. At 6 seconds, or sorry, that was at 4 seconds. At 5 seconds will be 3 more than that. 1, 2, 3. And then we start to slow down. So at 6 seconds, we only go 2.5 above that. So 1, 2.5. We get up to 16. At that point there, then we start to come back down. So we lose half a box there. And then down at 8 seconds, we're down to 16.5. I think I got a little bit off, but the basic shape here is going to be like that. I started to miscount them, but you sort of get the idea. Sorry about that mistake. So on this one now, they say figure out the velocity after 10 seconds. They want you to write equations and write out the words. I'll just say the words. So change in momentum is equal to change in velocity. So how can we list the change in momentum here? Well, it is final momentum minus initial momentum. That is the change in momentum. And we know that those two things can be written out as mass times final velocity minus mass times initial velocity. So now we can start to plug in for this. We know that the initial velocity is 0, so that just drops out. So we know that mass times final velocity is our change in momentum. And we've actually already solved for that because we figured it out over here. When we counted it up, our change in momentum overall from beginning to end is 14.5. So we can plug in our mass and plug in our change and solve for our final velocity. So 10 kilograms times the final velocity. The change in momentum is 14.5 kilogram meters per second. So just divide by 10 and you should get 1.45 meters per second is the final velocity of this box.